Thank you, everyone. It's a pleasure to be here. So we're going to talk about really what's new and interesting about the open source Spark NLP library. So I'll give a brief overview about the ecosystem and some of the things that are available for you right now. We'll talk a bit about Spark NLP 4, which is the major new release that came out just a couple of weeks ago. And then talk about just some of the things that we've noticed that you can do, but people generally don't know about. So this is usually useful stuff that hopefully at least some of these you can use in your own work. So Spark NLP has been around for less than 5 years, but really kind of fairly quickly became really one of the most used NLP libraries in the world. And when people go to production, it's the most used library in enterprises. So if you look at kind of healthcare, financial services, large-scale production deployments, people tend to shift to it. It's of course everything I'm showing you today is completely free, open source, Apache 2.0 license, right? So free for unlimited use, including commercial. The library has seen kind of really nice growth in terms of usage. And I guess, thank you, and thank the community for that support. In terms of what it does, so Spark NLP has, from the beginning, had the vision of being really an end-to-end library. So usually if you work within the Python ecosystem, you need to combine things, like to do some things with Spacey, and maybe some things you do with GenSim, and some things with Hugging Face, and you put them together. With Spark NLP, we wanted to get to a point where you could do everything within one pipeline. So in terms of the features, you have everything from the basic stuff, like tokenization, stemming, lemmatization, part-of-speech, dependency parsing, all the way to translation, summarization, question answering, and so on. The goal is to get to a point where you can build one pipeline. So first of all, just less code, more elegant. But then every pipeline is natively scalable. So you can train it locally, or you can train it on a cluster. You can do inference, or you can do inference on a cluster. Every pipeline is serializable. When you go from training to production, you just use the exact same pipeline, right? So there's never any question of did I remember to use the same embeddings or same tokenizer or exact same data preparation. It just makes things easier. Other than that, the library also comes, now there's actually more than 6,500 models that come within the Models Hub, and we'll talk a bit about the Models Hub that we have now in more than 250 languages, and that's only the free and open source version. In terms of comparison, so there are a number of public comparisons, but in terms of functionality, the goal was really to get to a point where, look, every NLP task you should be able to do within the library. Okay, so that as I said, everything is there, everything is scalable, everything you have it in Python, but you also have it on the JVM, which is something that some people want. Everything is trainable. Okay, so yes, of course you can train your own, emotion detection or question answering models, but you can also train your part-of-speech model or your sentence splitting model, and really every part of the pipeline, and you can share and reuse embeddings or transformers across the pipelines. One of the things we're really proud of, we've been doing releases every 2 weeks for 4.5 years now. And we're going to continue doing that, which means that really the library keeps expanding, and it's all public. You're welcome to go and check that those releases are actually fairly significant, right? And we keep adding functionality. Our main promise to you, to the open source community, to you, to our customers, is that we will keep you the state of the art. So really the main thing we do is we wake up in the morning, we read all the latest papers, we look at all the latest open source library. Every time someone claims that they have improved the state of the art and they have something that's more accurate in some way, we do 2 things. First of all, we check if it's true. So we check if it reproduces, and we check if it generalizes, right, beyond a specific data set or use case. And if it does, our job is to give you the production-grade, trainable, and scalable version of those models, right? So we started with, for example, XTRF for name entity recognition, and then there was BERT, and then there was LSTM, and now we have BERT for token classifications, right? And really what we have seen is that the state-of-the-art architectures, really they change every year, okay? So really, whenever you pick a library on implementation, it's never about, do they have this specific feature or algorithm? It's, will they stay this accurate, right? A year or 2 or 3 down the road, and that's where our focus has been. In terms of transformers, so Spark NLP comes with its own transformers, so you do not need any external library for that. And you have everything from word embeddings, sentence embeddings, document embeddings, token classification, sequence classification, multilingual ones, and kind of we pick the ones that in some way are best for specific use cases. We handle things like downloading them, making sure they're optimized, whether on CPU or GPU, making sure that if you are on a cluster, we actually distribute them on the cluster. If you're running a pipeline, right, so for example, let's say you're running spell checking, and then you name entity recognition, then you're doing relation extraction, right, and then maybe you're doing some text classification, you can reuse the same embeddings, right, so you don't have to load them multiple times or calculate them more than once. So we handle all those engineering aspects to make it simple. And of course, we actually not just give the embeddings, but also the algorithms that use them and give you the actual NLP tasks you care about. So all of that comes with the library, and we keep those up to date. And then the usual first question is, okay, where do they come from and how do you choose them? And for that, we've always had the Spark NLP Models Hub. Its role basically changed and clarified this year, especially because there are quite a few Models Hub that are available, right? And you've seen them. You've just had a talk from Hugging Face, which is amazing, right? And has that's the community place for all the NLP models, now ML models, right? So if you have a new paper, that's probably right where where you're going to publish it, right, or where you reproduce things that have been published before. So our goal with the NLP Models Hub was to do something slightly different. Was to make sure this is the right place for the models that are production-grade and ready. So the first thing we do, we actually collect models from different places. There are some models quite a few models we train on our own, but we basically scour the web for this and everything else, so that I can tell you that, look, if there's anything else that's better out there, we probably found it, and if it is better, we already got it in. Okay, so really, if you're looking for a language that is not supported, a task that is not supported, something that's more accurate, we probably have it already, because we have a team that actually looks for those and collects them for you. But of course, the important thing is not to just add everything to one place, as convenient as that is. It's also to know what to throw away. And there's quite a lot of stuff that we throw away. Okay, first of all, stuff that doesn't work, stuff that doesn't pass security checks, or stuff that is, if you want a text generation model that enables you to speak with Dumbledore or Hagrid or Yoda, that's not what we consider production grade. But everything that we think would be interesting in a production grade NLP application, we do take. Another place where we are selective, we make sure that when we have models, they're actually better in some way than what's already there. Okay, so we want things that are current, that are up to date. We want things that are not obviously superseded or worse than something else that's already out there, right? Because our assumption is look, if you use Spark NLP, then you are taking things to production, and you want to make sure that you have top accuracy right out of the gate. Okay, so what it means that we are definitely more selective. Okay, it also means that every model that you see with NLP Models Hub is something that a human actually tested and tried. Very often we fix documentation, we improve documentation, and you know that it works, right? And also, of course, this is all free for the open source community, but all of these, we have paid customers, we stand behind all of these, so you know that someone is actually checking that all of this stuff works. And there are quite a few models we have to retrain or significantly just change for speed or memory consumption. The other thing that you get when you use models from the NLP Models Hub is there are some other benefits that come just really by using the Spark NLP ecosystem. So first of all, you can combine models within pipelines, right? So you can use this part of speech with this lemmatizer, right? With this other spell checking thing, which is specifically tuned for the legal domain because this is what you care about. And then use pre-trained name entity recognition model with these cool embeddings that we got from somewhere else, and it's all one pipeline, right? And you can train or tune the whole pipeline together, right? Or of course, run inference. Everything's accessible on the JVM, right? So of course, there's a Python API, and there's also a Java and Scala API. So if that's of interest to you, really many of these models, that's the only way they're available on the JVM today, right, is through this ecosystem. Of course, there's the security and speed improvements that we put together with that you get with that. And there are other two interesting free tools. One is that for any model or any pipeline, there's a free NLP server. So if you want to serve it as a REST API, there's a Docker container that just does that with no code, right? So you just deploy the container, you say, here's the model I want, or here's the pipeline I want, and that's it. And you have it as a REST API. And that's something that's completely free, and you install and write privately. That's one thing. The other thing, all of these models are usable from the free annotation lab, right? So Johnson Lab's annotation tool that is free. So if you can reuse all of these models if you want to do automated pre-annotation, model tuning, transfer learning, also in a no-code environment. Okay, so all of that is there as well. So that's our goal with the Models Hub. And we're continuing it now, of course, really more tasks or more languages. And the goal is to come and say, look, if you want to get everything that's been ever published, you want to especially reproduce papers, you probably want to go to Hugging Face. If you want to take things to production, you probably want to use the models from here. Another thing we've put a lot of effort on over the past couple of years is making sure you can really use Spark NLP anywhere. On this slide, you're seeing all the officially supported and tested integrations. So these are places where we actually had to write code, write or test or documentation to make sure this works. So most people use Spark NLP from a local machine, right? So you can use it on Jupyter or PyCharm or Colab or Kaggle or just on your own Docker container and just run it that way. If you need to run it on a cluster, then you can do it on Databricks, or you can do it on SageMaker, you can do it on Google Dataproc, or you can do it on Cloudera, or you can do it on your own Apache Spark cluster that you build from source. That works as well. There are more and more integrations with MLOps tools, right? So MLflow, Comet, Synapse ML that come out of the box as well. And this, of course, will continue. Okay, so if you need to run it on Kubernetes, there's ways to scale that way too. In terms of Python, which is where most of the usage is, one of the things we spend a lot of time on is just making it simpler to use. And if you're not familiar with the NLU library, you just go pip install NLU, and it gives you basically all the models on the pipelines, including the ability to train, basically with one line of code. And you can see here on the screen two code examples. For one is for name entity recognition, and the other for document classification. So the way it works is NLU.load, and you put in the name of the model or the pipeline. If you go to Models Hub, it will have the names for everything, all several thousands of them. What load does, if it needs to, it will go to the internet, download the model. If it's locally or if you're in an air-gap environment, it would load them from the local cache. It would load all the embeddings that are needed, all the pre-processing. It will basically build that pipeline. And then when you give it text, it will just run it on the text and give you back a Python data frame. In terms of predict, as you can see here, it can take text. It can also take just a Python data frame, and then it gives you back a data frame with results. It can also take a Spark data frame. So if you really want to run this on a petabyte, it's the same one line of code. Just give it a Spark data frame. It also takes a Ray data frame, or any modern data frame, and can run at scale that way. Okay, so this is really, if you want to detect fake news, this is it. This is really all you need to do today. One last thing that we have that's the good resource that's been built up is the Demos Hub. And that's usually where people start when they start using the library, because really, it's kind of, okay, just show me something that actually works that I can copy paste and start with. There's about 150 Streamlit apps. So if you really just want to see, okay, what would happen if I type this text, or kind of what comes out of the box, and you have the nice visualizations to see, okay, does it do what I kind of understood it does? That's there, and you have about 300 Python notebooks to show you everything from, okay, here's the one-liner for the simple stuff, to here's the more complex stuff about how do I train models, tune models, right? Do transfer learning, combine different models, do multilingual stuff, all of that. So all of that is there, and we keep it up to date, and people contribute. So thank you everyone who has. That's usually another resource where people enjoy starting from. So that's overall around kind of the ecosystem and the progress we've made there. About 2 weeks ago, we released Spark NLP 4.0. So as I said, we have bi-weekly releases. Spark NLP 4.0 is a big release with the culmination of really several months of work from the team. and we're very happy with it. So it's a significant version upgrades of some of the underlying platforms, significant changes in terms of kind of the architecture and new capabilities. So I'd like to go over that. Basically, a new release, it does three things. It does more stuff, it's more accurate, and it's faster. In terms of doing more stuff, there are a few things, but one of the bigger ones is question answering. And we're talking about the classic question answering. You give me some text and give me a question. So if you look at this paragraph and you ask what is Spark NLP, you get an answer, and you also get basically the explanation where in the text they took this answer from. Okay, and there are quite a few models that will give you those answers for different aspects. The nice thing is, of course, the question doesn't have to be so simple in terms of, look, that example, you can basically, with the regex, find where it is in the text. So it also works if the question is not as obvious. And the nice thing, it also works if questions like are really not obvious, but like this actually works. You ask this question, you actually get this answer on this text. Okay, and it's kind of fun to test it with different things. But the point is, this is intended for open question answering. And if you give this to consumers, they're going to ask like super weird stuff, and they're definitely not going to use the words that you intended that they use, right? And they're going to use slang. At question answering, you're just going to copy paste stuff, and you want something that gives you something reasonable. So that's one question answering example. There are more than 1,000 question answering models that we've published now. Okay, here are the transformers they're based on. Okay, so we have basic question answering models for all of these transformers, and it's different. So if you really care about having something that's small memory, you may want to go with the Dilbert. In general, if you have the kind of examples you saw here, you probably want to go with Diberta if you're in English. If you have something multilingual, you probably want to go with XLM Roberta. If you have long text, for example, let's say you run as in legal text, and in legal they have like one-page sentences. I don't know if you've read it, it's amazing how long a sentence can be. You probably want long formers, right? If really you have if context that may be several hundred words away that may be relevant to an answer, long former does better there. So unfortunately, you do need all these choices, and you may want to experiment. And so really, we tested these. These were chosen out of the many question answering models there because each one of those actually has a use case where you may want to, where it may be the best fit. Okay, and there are quite a few others that I think would stay as kind of good academic results, but did not make that cut. And we just make it easy to experiment, right? It's really one line of code. You make the change. You can run multiple experiments and see what works best for your environment. Okay, I would say in the vast majority of cases, from what we've seen, you can use pre-trained stuff. And we've also have some models that are pre-trained for specific, of course, for healthcare, right? For finance, for legal, for other domains. In terms of accuracy, there's been several changes, but probably the most widely used NLP task is name entity recognition. For name entity recognition, right now, and this is Diberta on bird for token classification, we are getting to 96 accuracy on the dev test of CoreNLL 2003. And if you look at the comparisons versus things like versus Spacey, versus Flare, versus Stanford NLP, the only thing we're beating is the previous version of Spark NLP, which was already about a point more accurate. But we will keep doing that, right? So really, that's all we do. We try to improve our own accuracy on every task, and we'll continue doing that. And I said, really, it's never about what this year's state-of-the-art model is, because we've been doing this for 5 years. No model architecture lasts more than 6 to 12 months. Okay, it just it's super cool NLP. It's very fast-moving. There's tons of academic innovation. So really, what you should care about when you pick something is, okay, look, will they keep me at the state-of-the-art? Will they keep changing things? Okay, and anyone who's telling you that they found the cool new trick and it does slightly better than what is before, it's like, okay, so this will last for exactly 2 months, right, until someone finds something better. Okay, and that's just the reality of it. So that's name entity recognition. Another task for which we've now significantly bump accuracy across what we had before, but also across other open source libraries. So if you have Hugging Face, there's some libraries on top of Spacey that do this, is coreference resolution. Coreference resolution is basically looks at sentences like this and tries to correlate basically references to proper nouns. So for example, coreference resolution algorithm would tell you that in this specific sentence, right, she refers to Sally, and him refers to John, and the violin is just, that's its own thing, right? That's, in this specific sentence. And also, as you can see here, really you need to know that John is more likely to be a male name, and Sally is more likely to be a female name, right? So there's nothing in the grammar of the sentence that tells you that, right? You just replace the name. Right, so it's, and that's the challenge with coreference resolution, that sometimes in English, but really in every language, the grammar by itself will not tell you how to do this, right? And that's been for many years, when NLP was rule-based, right, or tried to really understand grammar, there were kind of limitations. But now we use embeddings, right? So we use a lot of pre-trained models that carry some of that. You can call it bias, you can call it, general knowledge, but those things work better now. And now, one of the things we've implemented is basically this paper for coreference resolution, which is fairly, I think the paper is about 2 years old, but kind of still holds as the best architecture we found. We've added some training data, we've added some, kind of hardened the models a little bit. But that's one area where, for example, if you're using coreference resolution models from, say, Spaces, Stanford, they're 2, 3, 4 years old, this will give you like a 10-point bump in F-score. Okay, so that's one thing to consider. Other than that, another big thing with Spark NLP 4 is speed. Spark NLP 4 comes with there are 3 builds. There's an Intel build, an NVIDIA build, and an Apple build. So first of all, Apple, this is probably right now the only deep learning of NLP library you can actually run on M1 and 2 at all. So TensorFlow, we actually had to build from source, right, for the thing to work. And we, first of all, I want to thank the 3 companies. We've, bothered the engineers long enough to, to make things work. With the NVIDIA, with the new release, basically what we do is, NVIDIA, they have their new chips. The new chips have actual new instructions, right, optimized for different things, and then they have their own libraries on top of them that make use of those optimizations. With NVIDIA, compared to Spark NLP 3.4, we're seeing really up to 8x speedups, okay, because really we've jumped several new versions in terms of the library because it's a new major version and we were able to do that. So we're seeing really across most of the transformers, you're going to be consistently much better speeds on GPUs. You're also going to see much better performance, but probably up to almost 2x speed up on CPUs. So if you're using Intel Cascade Lake, Ice Lake, right, we've basically done the work with Intel to use the libraries they've built specifically, so you actually get the speed benefits, and that's kind of that's something you get. Similarly with M1, as I said, that was a lot of build from source and really working with some Apple engineers to make sure that works. But the good news for you is that you really don't need to care about all of this. The only thing you need to know is, look, we've done all the work with the low-level library. We've tested them on all the clouds, all the platforms, different types of servers. So just use this, it's just going to be faster, right? And that's something, of course, we'll continue doing. Other than that, for Spark NLP 4, there's a whole set of new platforms and libraries that are supported. So new versions of Kubernetes, new versions of Databricks, new versions of EMR if you're on Amazon, new versions of Scala, TensorFlow. So you can expect it to work with the newest releases. One thing, the day we released this, Databricks released Spark 3.3. So so it's like, hey, we have the latest release, and it's like 3 hours later, it's like, no, you don't. That's just nature of the business. But I would say we actually tested, it actually does work on Spark 3.3, and it does work on Databricks 11.0 runtime. But we're adding automated tests, and we'll probably formally announce this next week. So that's Spark NLP 4, and you say it's pretty simple. It does more stuff, it's more accurate, and it's faster. And my main points to you is that we will continue doing that, right? And that's just all we do. It's just going to be more accurate, faster for the same task, and of course give you the kind of production-grade scalable performance that people use. I want to use the last few minutes just to show really some things that you can do with Spark NLP that people often don't know about, and it would be interesting to get feedback on those. So one thing you can do, you can also with one line of code, you can edit sentences for style. So you can do something like this. You can turn informal sentences to formal sentences to informal sentences. And there are other style changes that you can make. right? You can, if you prefer speaking in the third person, you can have it do that, or go the other way. And there are quite a few of those. So people do start using this for kind of, Grammarly-like, open source alternative. There's also a normalizer for slang. Okay, it's better in English, but it also exists for some other languages, and it's fairly easy to tune. Okay, so this is actually super useful if you're analyzing social media posts, right? And just as a data cleansing, data pre-processing. So if you're trying to do anything like, find topics, find sentiment, a lot of the models, especially if you have them pre-trained anywhere, they assume reasonable text, and text in social media is not reasonable. So, you can make it slightly more if you do it that way. And we've seen good accuracy bumps, really, and it's super easy. You just add one more step to your pipeline. It's pre-processing, and it does that. Another nice thing that's becoming a very big use case is building knowledge graphs. So, for example, let's say, and this is something that tons of people do, you read all of the latest academic research on COVID, okay, and you want to read all the abstracts and all the papers and come say, oh, we found that this symptom is related to this drug, right? This gene variant is related to this thing. This molecule seems to be, that's part of this other thing is related to this. And you're doing, for example, dependency parser relation extraction, and you find entities, and you find some interesting relations between them. And you want to load it into a graph. So one of the things we've added, and also this is all free and open source, there's a new graph extraction annotator within Spark NLP that basically extracts, you can extract triplets or RDF pairs, so that, like, seriously, 2 lines of code, you can load this into a graph database. We have a public blog post that shows this with NoSQL, right, on the free edition, right, so you can basically read free text data, understand it, extract out facts, put it into a graph, and then you can ask graph queries, which enables you, for example, to ask multi-hop questions, right? So questions that where the answer is collected across multiple documents, right? Or combine structured and unstructured facts within one data source. So that's available as well, and also something that more and more people are using. Another thing that's there, and people often ask us about, like, how do you do this? Is really just the ability to use models that were trained in one language, or to train your own model in one language and use it in many others. Okay, so for example, let's say you have a great, emotion analysis model for English, but you need one for Urdu or Catalan or Zulu or any other language. Really, what you can do, you have very nice pre-trained multilingual word embeddings. So you can really just take the pre-built model, use the embeddings that are there, just run your Zulu text against those embeddings, and you get results, and you get really fairly high accuracy results, right? And we're seeing both kind of academic papers, publishing results with this, and of course, production systems that seem to be pretty happy with it, super useful. You have translation, and also, this is free and open source. There are 2 sets of translation models that come within Spark NLP. So I'd say it's probably not as good as Google Translate, but it's definitely the best in terms of what's available right now, open source. It's also a good basis if you want to tune your own, right? If you have a specific domain, right? Let's say you're analyzing, trading requests and commands, right? Or analyzing, questions from patients in a clinical setting. It's a very good way to do this. We use it in our own when we sometimes need to generate data in different languages or validate, and it definitely works fairly well. And that's also, you can see the example codes here. It's literally 1 line of code to do a translation. Another thing you can do here, you can do things like you can ask it to translate Spanish to Spanish, which basically does paraphrasing. Okay, so it's a model that basically does simplification, which is also something that people often use. Another thing that you can do with Spark NLP is you can import Hugging Face models and the TensorFlow Hub models. Okay, so this is something we often get asked about. Oh, I found this on Hugging Face, can I import it? For about 25 different types of models, the answer is yes. There are usually 3 reasons to do that. Either you want to scale it, right? You want to run it at scale, right? And you don't want to pay anyone money. Or you want to run it on the JVM, right? So you want to make it possible on the ecosystem. Or you want to tune it and basically combine it with other models, right, within my pipeline. So it's just easier. You just and all of these examples are notebooks that show how you do those imports. So really, you can just take the notebook, just replace the Hugging Face model name, run it, and you have it running locally. And this is also something that you do on your own machine. So you don't need to share your model with anyone. You can do it in an air gap environment. right? And in general, nothing within Spark NLP usually ever requires you to have an internet connection other than the initial install and, of course, downloading models from the internet. We do a lot of work in healthcare and finance, so this is designed to run in high secure, high compliance air gap environments. Another thing that's sometimes useful is unsupervised keyword extraction. So also, it's one line of code. You can see it here. If you need to do something like really lightweight kind of topic modeling, clustering, unsupervised understanding of text, you have pre-trained models for English that basically do that. So they just try to understand text and tell you, okay, here are the keywords, and you can see some examples here. Very useful if you're doing initial exploratory analysis of text, you're building some word clouds, some visualization. Also, it's very useful if you're doing search and you want to be able to index keywords, right? Or show, did you mean, right? And you want to have you don't want to have, the as, did you mean? You want to have terms that are actual, entities and terms that would be of some meaning to the people who do search. Then this is one super simple way to do this. So, you don't need to train anything, to annotate anything. It just comes out of the box. Spell checking is something that once you know that you have it, and it's just one line of code, and you can just add it to the pipeline, you end up using it all the time. It has a very significant impact on the accuracy of downstream tasks. Okay, some embeddings are good with spell checking, with spelling errors, some are not. Okay, but just being able to cleaning spelling errors will definitely improve your accuracy if you're doing text classification, NER, question answering, translation, summarization, any other task. One of the nice things about Spark NLP model is the pre-trained model is that they can use context. So you can see the example here. I will call my sister. The letter S is missing. Due to bad weather, we had to move to a different sites, or we traveled to 3 sites in the summer, right? So sometimes you need to add a letter, delete a letter, replace the letter. And by the way, the word SITER is actually a valid word in English. It's a musical instrument. But in order to understand there's a mistake here, obviously you cannot do anything dictionary-based, rule-based. You need to understand the whole sentence, and you have a spell checker that does that. So really also, if you compare to other open source, but also commercial tools out there, you're going to see far fewer mistakes this way, and really more errors that get detected. So that's also something you have out of the box. Speaking of kind of data preparation, data cleaning, what do you do before you send it to advanced transformer models? The most important thing you need in your NLP pipeline is to split sentences correctly. And sometimes it's simple, or people always assume it's simple. Yeah, I just, if it ends with a period or an exclamation mark or question mark, then we're good, right? And I can do it with the regex usually, right? So, if it says like 3.14 or, I don't assume these are 2 sentences. But you have a problem if you're dealing with text that does not have punctuation. Okay, so it could be stuff like, medical text, right, or social media where people just don't do that. It could be OCR. It could be speech recognition text where you don't have it. So sometimes you actually need to understand the language to understand where to put in, commas and question marks, and that's a deep learning problem. So you have a pre-trained model that just does that for you, and also give it a go, try it, see how it works. And mostly people compare it. Usually people use the spacey stuff because even if you're on Hugging Face, you probably use spacey for sentence splitting. But if you have this kind of harder text, you have pre-trained deep learning model that do that for you. Toxic content detection is super popular, so we make sure we have a whole set of models that keep it up to date. And if multilingual, of course, trainable, one line of code, as you can see here. But also, if you ever wonder what's the difference between an insult and an identity attack, you have models that can show you what they think. But we deal with anti-Semitic text, sexually explicit text, all the types of garbage you can find online. You have models to find. Lots of fun for the whole family, but that's there. And one last thing I want to show is on measuring semantic similarity, also useful. So sometimes you want to see if 2 strings match, but sometimes you can see here they use different words, but they really say the same thing. Okay, so this is very popular if you want to see, like when people type a question and you can say, oh, here's kind of the closest knowledge-based article, right? This may help you, right? Even use completely different words. So that's also one line of code kind of thing, right? You can find the closest match, right, by using mostly sentence embeddings. And that's also kind of a super simple application that's kind of free, open source, and you can use. So those are some of the things I wanted to show you. As I said, all of this is free, open source. We do this for you. So my only request is please put this to good use, and please send us feedback so that we know what to do for you next. Thank you.
Thank you, David, for that amazing presentation. At this time, we'd like to open it up for questions if people have questions.
Hi. Thank you for the presentation. I thought that the capabilities are really impressive. So I'm still trying to grasp, like, how do we get the open source? Like, do we download a Maven package, a jar file, a Python package? How do we get started?
Sure. Yeah, so in terms of how you get started, yeah, you have one-line installers. There's a Docker container. You can just pipeline install. There's one-line installers for Colab, for local installation on SageMaker, on Databricks, on Colab, on Kaggle. There's a quick start page with, I think, about 8 or 9 different options.
Gotcha.
So just go to nlp.johnsonlabs.com, the link here, and it will show you there.
Thank you. And the second question, I looked up on Google. It says there's like a pricing portion, the not-free portion, that's charged by DBU per hour. Is that something separate from this, what you just showed today?
I did not understand the question. Can you repeat?
Oh, I looked up Johnstone Lab NLP, and I saw there's a portion that's not free that charges DBU per hour. So is this something is there like a differential? Is that like a different product?
Sure. So everything I showed you today is free and open source. We have 2 commercial products, Spark NLP for healthcare, that has several hundred models for clinical and biomedical NLP, and Spark OCR, which deals with form understanding and image understanding. Those cost money.
Okay. Thank you.
Sure.
Hi. First of all, congrats on the presentation. Really fantastic stuff. My first question is, in terms of capabilities for distributed training and inference, are they part of both the open source but also the commercial versions? And if yes, does it come out of the box, or do we need to use something like Horovod to distribute
training? So distributed training, distributed inference, it's all right out of the box. I mean, it's called Spark NLP because really it's the only natively distributed library. Yeah, there's nothing that you don't get in the free version in terms of capability, ability to scale, ability to use the latest and greatest hardware. That's all open source.
All right, awesome. My second question, do you have anything for automatic speech recognition in the roadmap, or do you have already as part of the product?
For image recognition?
Automatic speech recognition.
Speech recognition? Yeah. No, not at this time, no.
All right,
it's on the roadmap.
All right, cool. Thank you very much.
Sure.
I think we'll take one last question, and David can answer outside later.
Hi. I have a question about topic modeling. Mm-hmm. Is it possible to combine BERT with topic modeling so that if you, for example, if you have 5 records that are talking about fish and then other 5 records that are talking about seafood, so instead of putting them in 2 different buckets, they are similar and put into one topic?
Yes, so there are multiple ways to do that. One thing you can do is calculate the embeddings, right, and just do dimensionality reduction on the embeddings. With the NLU library, if you type install NLU, there's actually a bunch of visualization and Streamlit demos. So if you do nlu.load.viz, do that. So just try the visual. So if you go to nlu.johnsonlabs.com, look at the visualization tab. Some of the things do that. Okay. But say other than that, there's actually a different open source library. It's called BERT Topic, which does exactly that. So it's not Spark NLP, but if you want that, just look for a BERT topic. I mean, and that probably does exactly what you're asking for.
So the build topic is part of the Spark NLP?
No, BERT topic is a separate library, not ours. I'm not sure who the credit belongs to, but credit should go to whoever wrote it. But within Spark NLP, of course, you can do topic modeling. You can calculate embeddings in doing that way. But I think main thing, look at the NLU library visualization. I think it will do probably large parts of what you are looking for.
Gotcha. And just one more quick question. So when you do topic modeling, you said that you could do in different languages. Do you have to detect a language and then run separate models, or is it just one model does multi-classification?
So if you have multilingual data,
Yeah.
let's say you're dealing with tweets, yeah, just use a multilingual transformer.
Got it.
Like XLM or Bertha, yeah. But Spark NLP does include language detection, if you want to do that, right? So if you really want to do per things, yeah, you can have a pipeline that says detect language and then apply things per language.
Got it. All right, thank you.
Sure.
Thank you all, but David has graciously agreed to stick around, I guess, if you have questions, so please feel free to ask them. Thank you.
Okay, thank you everyone.